Good morning, Excel Geo. Now, the first video that you watched prior to this, that YouTube video, gave you a visual representation of the volume of a sphere and how it relates to a volume of a cone. Now, how did it do that? Now, let's talk about the sphere and the cone in which they gave you. Okay, so they gave me a cone. All right, so we had a cone. And then we had a sphere. All right, so we had a cone and we had a sphere. How were they the same and how did they differ? Well, we want to talk about this. The one thing that I want to emphasize is when we take a look at this is if I have I'm going to try to draw that cone a little better. All right, guys, there. Now, how are they related? How would this work? Okay, well, both of these, the cone and the sphere, had the same radius. All right, the cone and the sphere had the same radius. Now, in this case, the cone's height is here. That was equivalent to the diameter of your sphere. So the height of that cone was equivalent to the diameter of the sphere in that video. So how does that help me? Well, if we looked at that video, we knew that 2 of the cones equaled the volume of your sphere. When they filled up 2 of the cones with water, it was equivalent to the volume of the sphere. So let's talk about how they're related then. Well, if I think of one cone, right? I know the volume of one cone is 1/3 pi r squared h. That would be one cone. So if I think of 2 cones, I would just double that value. I would say 2 cones, it would be 2 times 1/3 pi r squared h. That would be the volume of 2 cones. That would be equivalent to the volume of my sphere. But let's talk about this. In a cone, the height was represented by the diameter of the sphere. So I can easily say, if I look at the volume of my sphere, and let's also make note that the diameter is also equivalent to 2 times that radius. And the reason I want to use it in terms of radius is because then our whole entire equation has a variable of r as opposed to having 2 variables. So if I think of this, we just saw that the volume of 2 cones is the same as the volume of the sphere. So I can now say that my volume of my sphere would be equal to, what would that be equal to? It would be equal to 2 times 1/3 pi r squared. But guys, instead of h, I can now substitute 2r because the diameter is equivalent to the height, but 2r is the same as my diameter, and I could substitute in that 2r. And the reason I'm going to do that is because now I have everything in terms of r. So let's look at that. What is the volume of my sphere? The volume of the sphere, let's simplify that, would be, let's see, 2 times 2. I got 2 times 1/3 times 2. That would be 4/3. I have a pi, and then I have r squared times r, which would be r cubed. This here is my volume of my sphere formula. And that's how I can derive it. All right, guys? So I want you to now look at that PDF form that I attached because we're going to be going through that now. So I'm going to take that formula and I'm going to put it here, the one that we just derived. The volume equals 4/3 pi r cubed. The one we derived by taking 2 cones and deriving the volume of that sphere. All right. So guys, let's use this formula now. An example one says, find the volume of a sphere with radius 12. So we just have to input this in. So I now know my volume is equivalent to 4/3 pi 12 cubed. Now, if I asked you for the answer in terms of pi, I would just cube 12 and multiply it by 4/3. Okay, and when we do that, let's take a look. We're going to do that. We're going to take 12 cubed and then multiply it by 4/3. And you should get the volume to be 2,304 pi. Now, they don't have units there, so we're going to put a UN, and you're going to put units cubed. If I wanted you to give me an estimation, meaning rounding and approximation, you would plug this into your calculator and get 7,238.229 units cubed. All right, guys? And that's how we're going to be able to calculate the volume of a cube. So depending on what I asked, exact value in terms of pi, estimation. All right? Let's look at number two, example 2. Slightly different. We're going to just look at it from a different point of view. A standard bowling ball cannot be more than 27 inches in circumference. What is the maximum volume of such a ball? So that means if 27 inches in circumference is your max circumference. So that means when I take a look at this problem, my max circumference would be 27 inches. And how am I going to use that? Well, in order to find volume, we need to know the unknown variable of r. So we're going to use the circumference to help us calculate what r is first. So remember, our circumference, when they're saying the max circumference, they're talking about the great circle in your sphere. Now remember, the great circle is the largest circle of the sphere that breaks the sphere in half. So if I take a look at that, that means the circumference of that great circle, which would be 2 pi r, would be equivalent to 27. Now, the radius of a great circle of a sphere is the same as the radius of the sphere. Okay, so be aware of that. Now, if I solve for r here, I would divide both sides by 2 pi. Now, be careful when you divide by 2 pi in your calculator, you have to put the 2 pi in parentheses in the denominator. So your radius would be approximately, if you put it in, make sure that's in parentheses, your radius would be approximately 4.297. And that would be inches. That would be the max radius. Now that we have it, the max circumference would give me the max radius of my bowling ball. So now I'm going to use that in my volume formula. So in my volume formula, I can now state your volume is 4/3 pi r cubed. So you're taking that 4.297 and you're going to cube it. And you're going to get an approximation. So if I cube that, and then I multiply it by 4 divided by 3, and then times it by pi, I'm going to get 332.4342. Now, if you just used your answer, you would have gotten a different answer, which is correct. If you just put in 4.297, this is what you would have gotten. If you input in just like second answer in your calculator, it would have been like 332.384. And I would have accepted both on an assessment. All right, guys, depending on how you did it. But if you do round in the middle, please round to 3 decimal places to try to keep it as accurate as possible. All right, guys? All right. So right now, let's take a look. So that should have been your answer. Make sure the other thing I want to emphasize is make sure that your answer is cubed. Your answer should always be cubed. Because when we're talking volume, your answer should always be cubed. I expect everybody to have a cubed answer when they are answering a question on an assessment. All right. Okay, the next thing we're going to talk about with the sphere is surface area. And that would be if I thought of a ball. Why is surface area valuable? Well, surface area is valuable because I would think of the material to make like the beach ball, the material to make the soccer ball, the material to make a baseball. All that is the surface area of my sphere. So if I take a look, your surface area of your sphere formula will be, okay, my surface area of my sphere will be 4 pi r squared. That is my equation for surface area of sphere. So let's use that surface area formula to solve example 3 and 4. Let's start with 3. Find the surface area of a beach ball with radius 20 centimeters. Now again, we're back to surface area, so therefore when we talk about units with surface area, we're doing centimeters squared in our answer. All right? Volume cubed, area squared. So if I look at the surface area of a beach ball, I know our formula is 4 pi r squared. Well, my radius is 20 and it's 20 centimeters. So I'm going to square that. If I asked you for the answer in terms of pi, what you would do is you would do 20 squared times 4, and you would get 1,600. So you would say your surface area would be 1,600 pi centimeters squared. That would be an exact answer, an answer in terms of pi. If I said you could approximate it and round it, you would just multiply that 1,600 by pi, and you would get your answer to be 5,026.548. 5,026.548, again, centimeters squared. This would be a rounded estimation, that rounded answer, as opposed to an exact answer. All right, guys? And that's a basic way to find our surface area of a beach ball. Now let's approach example 4. Again, we're just looking at it in a different way. A bowling ball has a surface area of 232 pi inches squared. What is the diameter of the sphere? So in this case, they're giving me the surface area. They're telling me what it is, and I have to find the diameter. Well, the diameter is double our radius. So if we're able to calculate the radius using our surface area formula, we would just double it to find our diameter. So if I take a look here, let's take a look at what we're going to do. So if I take a look, I would say the surface area, 232 pi, would have to be equal to 4 pi r squared. And I would solve it like an algebraic equation. I would divide by 4 pi, and conveniently, my pi's would just cancel. And I would have 232 divided by 4. And you would get 58. So you have 58 is equivalent to r squared. And unfortunately, that is not a perfect square, right? So we know it's not a perfect square. Does it have a perfect square factor is the next thing you want to do. Now, the reason that would become valuable is if you wanted to ask yourself for an exact answer versus a rounded answer. Now, if you think of 58, the only two numbers that multiply to 58 are 2 and 29, which are both prime, so therefore it does not have a perfect square factor. So you can say that r would be equivalent to the square root of 58. If that's the case, I can double it to find my diameter. Then my diameter would be 2 root 58, and that would be in inches. Now, this would only be if I asked for an exact value, because I didn't round. If I'm allowing rounding, meaning I did not ask for an exact value, you would first find your radius. Okay, you would say, what's my radius? My radius is the square root of 58. And if I found the square root of 58, I would get 7.616. Okay, and then I would double it to find my diameter. And if I doubled it, it would be 15.232. Okay, and again, inches, because that is the units which I'm given. All right, guys, that is your lesson for today. Your assignment is below. It's textbook work. If you have any questions, please come visit me during my office hours. I hope you all have a great day today.